Very good afternoon, guys. So we are solving the problems based on relative velocity, and already I dictated one question, one problem. That is, we'll solve that. Then after we'll go with a new topic. On a two-lane road, already I dictated on previous day, that is on Friday. On a two-lane road, car A is traveling with a speed of 36 kilometers per hour. Two cars B and C approach car A in opposite directions with a speed of 54 kilometers each. At a certain instant, when the distance AB is equal to AC, both being 1 kilometer, B decided to overtake A before C does. What minimum acceleration of car B is required to avoid an accident? So what he said is, he considered a two-lane road. He considered a two-lane road like this. Now on this lane, a car A is going in this direction. In this direction. Two B and C approaching car A. That is nothing but, if this is the car B and if this is the car C, car B and car C approaching car A. So in this direction, in this direction. So initially, both the cars are moving with the same velocity, are approaching. Now when these two cars, that is the distance between car A and car B and the distance between car A and car C, both being 1 kilometer. 1 kilometer is nothing but 1000 meter. Then the driver of car B wants to overtake car A before car C does. So that means before car C overtakes car A, the car B want to overtake car A. Then, since these two are moving with the same velocities, what the velocities he gave? Velocity of the first car one second. Velocity of, on a two-lane road, car A is moving with a speed of 36 kilometers per hour. So velocity of car A is 36 kilometers per hour. If you convert into meters per second, so you need to multiply with 5 by 18, which is equal to 10 meters per second. And the car B and car C approaching in opposite directions to car A with a speed of, both moving with the same speed. VB is equal to VC, which is equal to 54 kilometers per hour. Again, if you want to convert into meters per second, it should be multiplied with 5 by 18. 18 ones, 18 threes. So 15 meters per second. So the car B and car C are moving in opposite directions, the same speed. Since they are moving with the same speed, definitely they will reach this point at the same time. then definitely the accident will take place. To avoid that accident, the driver of car B wants to overtake car A before it does, before car C does. Then definitely he has to increase its speed. He has to increase its speed. So then what will be the acceleration of car B in order to overtake car A before car C does? That was the problem. So here the thing is, what we need to do is, first I would like to find how much time the car C will take to overtake car A. How much time will it take? For example, it takes a time of 20 seconds for my convenience. The car C is taking a time of 20 seconds to overtake car A. That means the car C is taking a time of 20. It's not the correct, just I'm telling to understand. If the car C is taking a time of 20 seconds to cover 1000 meters, then what we need to do, the car B has to overtake car A before 20 seconds. Before 20 seconds. Then only the accident will not take place. Understood? So, in order to overtake in 20 seconds, within 20 seconds or below 20 seconds, what should be the acceleration required for the car B? That was the problem. Okay. Now, here I want to find out how much time the car C will take to overtake car A. Here both the cars are in motion. Whenever both the cars are in motion, try to approach the relative velocity concept. Try to approach the relative velocity concept. Now, so what is the common distance both the car A and car C is traveling? What is the relative distance both car A and car C are traveling? So both together is traveling 1000 meters only. Both together is traveling 1000 meters only. That's why the relative distance traveled by car A and car C is 1000 meters. Okay, na? So here, since both are in motion, that too in opposite direction, there will be a relative velocity. First, I would like to find the time taken by, listen first, by car C to overtake car A. Time taken by the car C to overtake car A. So here both in motion, relative distance. Then what I can write? Relative velocity of C with respect to A is equal to relative distance traveled by C with respect to A by T. Distance by time will give the velocity. Okay, now relative distance, relative velocity of car C with respect to A is equal to, velocity is equal to distance by time. Here I am taking the relative distances and relative velocities because both the cars are in motion. Now, here the car A and car C are moving in opposite direction. Since they are moving in opposite direction, what will be the relative velocity? So VC plus VA will be the relative velocity of car C with respect to car A is equal to SCA by T, where VC is equal to 15, VA is equal to 10. So 15 plus 10 is equal to 1000 by T. Relative distance traveled by these two cars together is 1000 meters. So therefore T is equal to 1000 by 40, sorry, 1000 by 25, 15 plus 10, 25. 1000 by 25, which will give 40 seconds. So the car C will take a time of 40 seconds to overtake car A. So now what the car B has to do? what the car B has to do? It has to travel or it has to overtake the car A within 40 seconds to avoid an accident. Okay, now? Now again what I need to do now? I need to do relative velocity concept. Why? Because again here car A and car B are in motion. Then what is the relative total distance traveled now? Here is also, it is moving and it is also moving. The relative distance traveled is 1000 meters only here also. So the total relative distance in a total time of 40 seconds. Then which formula shall we need to approach? S is equal to ut plus of at square. Here the motion is between B and A. The motion is between B and A. So the relative distance traveled by car B with respect to car A is equal to U means initial velocity. Here initially both are in motion. So I am taking initial relative velocity. What is the relative velocity? Velocity of car B with respect to A into T plus half relative acceleration. Acceleration of car B with respect to A, T square. This step is very, very important. Here both the cars are in motion. So whenever both the bodies are in motion, we have to consider relative velocity, relative acceleration, if is there any acceleration, and relative distance. S is equal to ut plus of at square. So we can do it like this. So what is the relative distance? Both are traveling, both together are traveling here 1000 meters. That is the relative excess distance. It is in motion, it is also in the motion. But how much distance this car B has to travel more? 1000 meters. That's what we discussed in previous problem also. The additional distance traveled by car B with respect to car A is 1000 meters. Additional distance. Okay. Because after 40 seconds, definitely the car A will be somewhere here. After 40 seconds, the car A will not be here. Why? Because it is in motion. Whenever it is in motion, the car A will be somewhere here. So the car B has to travel this distance plus this distance to overtake. Already we discussed this. This distance and this distance to overtake. But this is the common distance traveled by car A and as well as car B. What is the additional distance? The car B only traveling 1000 meters. So that is the relative velocity of car B with respect to car A is equal to now SBA is equal to 1000. Relative velocity, here both the cars are in motion and moreover in the same direction. Since in the same direction, the relative velocity of B with respect to A, we can get VB minus VA into T plus half AB minus AA, because both are in the same direction, accelerations, into T square. Now VB minus VA, VB is equal to 15, VA is equal to 5. So 15 minus 5, which is 15 minus 10, which is equal to 5. So 5 T. T is nothing but 40 seconds. Minimum time I am taking. So it has to be before 40 seconds only, but the minimum time is 40 seconds. Plus half acceleration of car B we need to find minus acceleration of car A. This car A is moving with uniform velocity only. There is no increment in its velocity. So the acceleration of car A is 0 into T square. T is nothing but 40 square. Now if I further simplify, 1000 is equal to 540s are 200 plus half AB 40 square is 1600. Now 800, I mean 1000 minus 200, 800, 1600 by 2, 800. So the answer will be 1 meter per second square. Like that we have to do. So first what we are doing, how much time the car C will take to overtake car A. First I am finding the time. Within that time only, the car B has to overtake car A. Ashte. Okay. I hope you copied. Okay. Now, equations of motion called V is equal to U plus AT, S is equal to UT plus half ET square, all those are. Those equations will be used when the bodies on the body or an object is moving in a straight line motion, that too uniformly accelerated motion. That means if a body is moving, if and only if with constant acceleration, then only we can make use of those formulas. V is equal to so. I derived those formulas in a manual way. I derived the formulas by using the velocity time graph. The same formulas I would like to derive by using one mathematical phenomena called as calculus. Calculus will have the two parts called as a differentiation and integration. So that the differentiation and integration will be used mainly in physics to solve many problems in a simple manner. But still now we solved very tough problems, very lengthy problems, and those derivations also a bit lengthy. So before deriving those derivations, I would like to discuss one more concept which will be interesting to you. After that, again, we'll go for that. Still now what we discussed is horizontal motion, that is the straight line motion. Now I would like to discuss vertical motion. Vertical motion. Vertical motion is nothing but when a body is moving vertically upwards or vertically downwards, such type of motion. This motion we call it as an vertical motion. Here, since childhood, you might be learning that whenever you project a body vertically upwards, if you project a body, that is projection is nothing but throwing, nothing else. If throws a body vertically upwards, definitely the body will not stay here. The body will not stay here. Definitely the body will comes back to the point of projection or come back to the ground or come back to the earth. Then why the body is coming back? Why the body is not staying here only? That question arises. So there everybody knows that here there will be a gravitational force. Because of the gravitational force, this body will be attracted towards the ground. Then what do you mean by this gravitational force? Gravitational force. So in our lower standards, that is in previous classes called either 10th or 9th or 8th, you might be studied about this gravitational force of attraction. So the gravitational force is nothing but the force between any two bodies. The force between any two bodies. Simply we can call it as due to their masses. Due to their masses. But frankly speaking, there will be a small particles called as gravions and all. We'll discuss later. But as a layman's language, we can say that whenever two bodies having certain mass, there will be a force of attraction. There will be no repulsion. The word repulsion you might be studied in case of the charges. In case of the charges, there will be an attractive force as well as the repulsive force. Both will be there. As we know, unlike charges attracts and like charges repulse. But as for gravitational force is concerned, there will be only attractive force. Now you might be studied according to Newton's law of gravitation. Two bodies having certain masses m1 and m2 separated by a certain distance r. then the force of attraction between these two bodies is directly proportional to product of their masses according to Newton's law of gravitation, and inversely proportional to square of the distance between them. Directly proportional to product of their masses and inversely proportional to square of the distance between them. From there I will write F is equal to some constant G, m1 m2 by r square, where G is called as a gravitational constant, that is universal gravitational constant. Its value is 6.6 in 10 to the power of minus 24, like that, minus 11, sorry. So these are all you might be studied. So from there what I can say is, whenever two bodies are separated by a certain distance, definitely there will be a force of attraction. But that force is very less. Gravitational force is the weakest force in nature. So the force will be very less. Okay. And since the G value, we are calling it as a universal gravitational constant, that means its value remains constant throughout the universe. So that is nothing but G value will not vary with respect to a medium. If you take the two bodies in air, or if you take the same two bodies in water, the G value will not change. G remains constant. That's why it is called as an universal gravitational constant. So what are the features of a gravitational force now? What are the features? One is the gravitational force is only attractive force. Other one is, since the G value is constant throughout the universe, the gravitational force does not depend on the medium between the two bodies. Because if the medium between the two bodies is air, G value is same. If the medium between the two bodies is water, the G value is same. So it does not depend on the medium between the two bodies. Then what factors it depends? It depends only on their masses and the distance. Okay. And if you want, I can say that the gravitational force is the central force. Central force is nothing but the gravitational force will always act along the line joining the centers of the two bodies. Along the line joining the centers of the two bodies, the gravitational force will act. Like that, we can say many points regarding the gravitational force. But here concept is, the gravitational force and gravity is both one and same or not? That question is this. Is there any difference between the gravitational force and gravity? Gravity and gravity. So here only one difference. Gravity is also one type of gravitational force only, there is no doubt on that. But the gravitational force will exist between any two bodies having certain mass. For example, you take two chairs, there will be a gravitational force. You take two benches, there will be a gravitational force. Or you take two tables, there will be a gravitational force between them. In those two bodies, if one body is Earth, among those two bodies, if one body is Earth, then the gravitational force between the Earth and any body is called as gravity. So here I mean to say that the word gravity will be used if and only if among those two bodies, if one body is Earth. Why? Because the gravitational force may exist between any two bodies, but whereas the gravity is between only Earth and some other body. Understood? If there is a gravitational force between the Earth and this chalk, that is called as a gravity. So if you consider the force between the two chalks, that is the gravitational force. Okay. So the word gravity will be used. Again, I'm saying, insisting you. The word gravity will be used if and only if one body should be Earth. For example, if this is an Earth and here some other body is there, then the force of attraction between these two, we call it as a gravity. Yavaga, if it is Earth. Instead of Earth, here is also, if you take any other body, then it should be called as a gravity. It should be called as a gravitational force. Just a difference. Okay? If I say, when a body is projected upwards, if a body is projected upwards, definitely the body will comes back because of the gravitational force. If I say, definitely it is a wrong statement. What the word I should use now? If a body is projected upwards, that will comes back to the earth because of gravity. Understood? Because of gravity. Okay? So whenever we are dealing with the vertical motion, we have to concentrate more on gravity. We have to consider the effect of gravity also. Understood? So whenever we are dealing with the vertical motion, either it may be upward or it may be downward, never mind. But we have to consider the effect of gravity. Okay, now here for example, if somebody drop a stone on my head, somebody dropped a stone on my head from certain height like this, then definitely some hitting will be there. If the same stone is dropped from further height onto my head, here is also the hitting will take place. But here my question is, in both the cases, is the impact is same on my head or not? That question arises. Definitely not. If something is falls on my head from a shorter height or less height, immediately what we'll do like this, we'll do. It's finish. If the same body is dropped further height, then definitely if it hits on my head, definitely will sit like this. That means the impact will be more. Why the impact will be more? Because the stone which is coming from further height is hitting my head with higher velocity. Is this higher velocity is impacting effect or not? Definitely, because once if I hit the board slowly like this, nothing will happen. If I hit the same board with very fastly, definitely I will get pain. That is nothing but whenever the velocity is more, the impact will be more. So here, whenever a body is falling from further height, I am getting more impact is nothing but at the time of hitting my head, the velocity of the stone is more. That is nothing but there will be an increment in the velocity of a stone. When the increment of the velocity will be there, if there is an acceleration. So here, I mean to explain you, if I drop a body from certain height, definitely this body is getting some acceleration. From where the body is getting an acceleration? That question arises. For example, if you take a body like this, initially this body is at rest. Now I want to make it into a motion. Then what we'll do? We need to apply a force. So I'm applying a force. If I apply a force, F is equal to ma. General formula. F is equal to ma. So whenever there is a force, there will be an acceleration. A body simply will not get an acceleration. Andre, instead of using the force, if I see like this body will not get acceleration. A body is getting an acceleration is nothing but some force is acting. Here is also a body is getting acceleration. How this body is getting an acceleration? Some force is acting. What force is acting on the body now? Called as a gravity. Gravitational force. Because the one we are taking as an earth, it is a gravity. So, whenever a body is dropped from certain height, or whenever a body is thrown downwards from certain height, the body will acquire, the body will get, the body will possess acceleration. So the acceleration acquired by a body due to gravity, we call it as an acceleration due to gravity. So in vertical motion, we have to think of acceleration due to gravity. Put a side heading, acceleration due to gravity. Acceleration due to gravity. First point. First point. The acceleration acquired by a body, the acceleration acquired, A-C-Q-I-R-E-D, acquired by a body due to gravity is called acceleration due to gravity. Is called acceleration due to gravity. Now you know what is gravity, how the body is getting acceleration, everything. Next point. It is denoted with a symbol small g. It is denoted with the symbol small g. So here, this is an earth. If you drop a body like this, if this is an earth, see the board, if this is an earth, if you drop a body, definitely the body will get acceleration in this direction. Then what is the direction of acceleration due to gravity? The direction of acceleration due to gravity will be always towards the center of the earth. Next slide, next point. The direction of acceleration due to gravity the direction of acceleration due to gravity is always towards the center of the earth. The center of the earth. So here, for one simple thing, two bodies I am dropping from the same height. Two bodies I am dropping from the same height, but two bodies with different masses. For example, you can take me in one hand, you take elephant in other hand. Then you drop both at the same time. you drop both at the same time. Then what happens? Will it, myself and elephant will reach the ground at the same time, or the first elephant reaches, then after me, or first me, then after elephant? So this question arises. These are the queries in front of us. But by seeing the scenario, we can say that, generally we'll say that, we'll feel that the elephant will reaches the ground earlier anta. Elephant will reaches the ground earlier anta. Now telkontive, we'll imagine, we'll consider, but it's not so. Both myself and elephant will reach the ground at the same time. Why? Because the value of acceleration due to gravity does not depend upon the mass of a body. You may say that. You may say that instead of elephant and me, you take one piece of paper and stone. If you drop both at a time, definitely the stone will reach us. Practically we've seen many times. But here, the definitions and statements will be there only in ideal conditions. Ideal conditions. Ideal conditions andre, if the same experiment you do in vacuum, where there is no opposing forces, nothing, vacuum. If you drop the stone and a piece of paper both at a time in a vacuum, definitely the both stone and paper will reach the ground at the same time. Okay. So next point you note down, the value of acceleration due to gravity. The value of acceleration due to gravity does not depend on the mass of your body. Why it does not depend? And everything will do it tomorrow, no problem. Okay. Still lot more points to discuss about acceleration due to gravity, because if you have a strong knowledge, strong basic knowledge regarding acceleration due to gravity, then we can apply it